Okay, here we are at the workbench. I have the H3000 here. First thing that you're going to want to do is using a Phillips screwdriver, take out the 9 coarse threaded screws that are around the perimeter. They're a small black screw. And then remove the 2 fine thread screws and keep track of which one is which. There is a long screw and a short screw of the fine thread type, these two guys here, and the longer goes into the rear hole, the shorter goes into the most forward hole. This is the front of the machine here. I've got a little magnetic dish for keeping track of hardware. I'm really familiar with the inside of these machines. If you are not familiar with the inside of these machines, a good tip is to use small sandwich baggies. After each step, place the screws or hardware that you removed into the sandwich baggie and label it. Moving on, we're going to open up the H3000. Just set the top aside. So what we're going to be doing today is addressing several different things. First, we're going to be doing an overview. I'm going to talk about proper practice and procedure, and then we'll dive into what we're going to do. So you'll notice that I'm wearing plastic gloves. This is an anti-static precaution. I also have a ground strap on my ankle, and I'm working on a grounded workbench. These are precautions that you must take to prevent electrostatic discharge. You know, when you walk across a carpeted room and you touch the doorknob and you get a zap on your finger, those little zaps can be in the order of thousands of volts, tens of thousands of volts. Very, very, very low amperage, but high voltage, and those high voltages can fry these sensitive chips in this machine and render it dead. DOA. You don't want to brick your Eventide H3000 and have to send it to us for repair. So take precautions. So what we're going to be working on today, 4 things. First thing we're going to be looking at is the LCD. This machine has already been upgraded with the OLED display. I'm just going to be talking about how you do that procedure and giving some tips and some advice. Secondly, we're going to remove the original power supply. That consists of this transformer, Schottky diode, and this 5-volt power supply on the back. This will all be replaced with our replacement. This is a kit that we offer. This is the synthesizer repair toroidal transformer replacement, and it sits nicely in there. Once it's installed, you no longer need to have this old school LM style 5-volt power supply. Regulated 5-volt power supply is provided by our upgrade. Once we've got the power supply out of the way, it will allow us to access the operating system chips, as well as the NVRAM. If you have multiple upgrades to do on a machine, such as power supply, display, general cleaning, and operating system or NVRAM, it's really good to do it all at once. The less times that you have to open up and prepare a workspace, the better, because the less opportunity you have to accidentally cause damage to the machine. So the first step that we're going to do, we're going to use the flush cut dike to remove all of these stock zip ties. Now, if you weren't doing the power supply, you wouldn't bother with this. However, if you know the Eventide H3000 and all of the units in the series suffer from the same problem. These transformers buzz, they hum, they rattle, and it is a well-known downside to these awesome effects machines. That's why we engineered our upgrade kit to forever get rid of that hum. Also, something that happens over time is these 5-volt regulated power supplies slowly start to produce less and less amperage. You see your 5-volt rail drop, and when the logic of the machine doesn't have enough amperage supply 5 volts, the voltage drops down into the 3.9 volt area, and all of this logic just starts to fail. It relies on good, consistent 5-volt power. Transformer is held in with flathead screws and nuts on the other side. We'll get to that later. The front panel comes off with 4 Phillips screws. These spade connectors come from the power supply to the main power switch. You can just wiggle them carefully and they pull out. Sometimes the plastic insulation might pull off first. It's okay, just push it back on. It's important to have something to support the display front panel. This is a soldered ribbon connector. You want to be careful with it. It's not super fragile, but it is definitely delicate. So the next thing that you need to do to be able to free this front panel is you have to take off the encoder knob. Again, you need a flathead screwdriver. You just gently hold on to the encoder knob from the underside. Remove this screw with your flathead and pull the knob down. There is a plastic washer underneath the encoder dial, a metal washer on the top, and a flathead machine screw. Set the knob aside and make sure not to lose the hardware, remembering that the plastic washer goes towards the PCB side of the encoder wheel and the metal washer goes on top of it. This, when it is screwed back in, does not need to be screwed in with very much torque because it is not under any mechanical load. All that it does is spins that little encoder wheel. The next step to install your OLED display is to remove the solder on the 14 pins that transmit power and data to the display. Additionally, on the stock display, there are 2 leads that provide power to the optoelectronic backlight. Those can simply be cut with a flush cut dike, like so. After you have your display unsoldered cleanly, then you can undo the 4 machine screws and set the hardware aside. You will reuse it. Once you have the display out and off to the side, then you can go ahead and disconnect the front panel PCB from the aluminum plate. There is a singular capacitor that must be unsoldered and relocated to the front. It is a polarized capacitor, so you must take note of the positive and negative leads and make sure that they get put back in the proper orientation. There is a header included with the OLED display kit, but it is not necessary to use it. It is just included for convenience in case your original header needs to be replaced. When we do this installation here at our shop, we always leave the header in place. Simply place the new display where the old display was, solder it in place to the header after reattaching the hardware, and place everything back together, basically just like you took it apart, and then you'll have a nice OLED up display update. The display kit also includes a polarizing lens. This polarizing lens filter is a really nice addition to add to the machine for several reasons. Primarily, it keeps dust and debris and other stuff from getting onto your display. It also protects the OLED display, which is equally fragile as the LCD display, but it will protect it from any impact. And the third thing is that it just looks very professional. It looks very nice. Okay, so now that I've covered the display, and again, if you have any questions, don't hesitate to reach out to us, support@synthesizer.repair. We'll help you along the way. Now let's dive into the power supply. So I'm going to start by unplugging the power supply from the main board. And then I'm simply going to take out the hardware. When we're doing the power supply, we also want to remove the screws from the bottom plate. You notice that I have a screwdriver here that has a really substantial handle. This is a tool that's made by a German company. I really like these screwdrivers, but it's good to have one that has a good handle so you can get torque on this screw and break that epoxy free. Our power supply has jumpers to allow selection of the voltage when you install it. So we don't use this switch. It basically just becomes dead weight. I like to leave some of the leads, so I will just cut these about midway. The way that you do this is you move the wires around and underneath the transformer, and that will allow you room to slip it by. It's a little tricky. This transformer is pretty heavy, weighs about 2 pounds. I like to leave some of this wire There is a Schottky diode here that regulates the center tapped secondary winding of this transformer. Because our new power supply has a bespoke regulated 5-volt output, we no longer need this part. I just cannot say enough good things about these VHA screwdrivers. They are just so cool. See how this is adjustable in length? Got a Phillips on one side, flathead on the other. They make a ton of different adapters for these screwdrivers. Okay. So the way that this is connected on the back here, it just has kind of like a plug. So as we prepare to install our power supply, we have to make some modifications to the original wiring harness. You notice there are 3 wires here on the end, blue and gray. The colors, I believe, are the same across all of the 3000 series, but they may vary. If you are in the process of installation and you notice some difference, please reach out to us and let us know. Send us a picture of what you have in your machine. Anyways, these 3 wires on the end of the harness brought power in from the transformer, and that power was then converted into the 5-volt DC via an onboard circuitry that converted the AC unregulated into regulated DC. Because our power supply provides us with a regulated 6 amp 5-volt DC supply, we do not need these to be connected to the board. The circuitry that's in place can remain. It doesn't need to be removed. The way that these old school Molex connectors work is on one side you have these little slits. You can take the blade of a flathead screwdriver and just gently push in, just gently push in on these contacts, and a little bit of coercion usually just pull right out. Use a wire stripper and expose some wire. You do not need to tin the ends of this wire. However, it's advisable. I'll go do that now. So I've tinned these wires. After you put some solder, i.e. tinning the ends of these wires, it's a good idea to take some isopropyl alcohol, 99% isopropyl alcohol, and a paper towel, and just clean them off to make sure that they're good and clean. So we're going to reuse some of the wires that we removed. We have our brown wire, which is our neutral, the AC coming in that's going to be running our analog. This is coming in at 30 volts from the transformer. It's center tap. And then they're going to go on to be converted filtered through the filter capacitors and converted into 15 plus minus DC that runs the analog portion of the board over here. We want to use the green wire, keeping with sort of like normal conventions. Green is usually a common or ground. In this particular configuration, we're going to have these 3 to the farthest side are going to provide our AC, which I just discussed, and then we're going to have ground coming in from, or common coming in from the 5-volt supply, and then 5 volts. So first thing we're going to do is move this green wire over. So same process as before when we were removing these. And after you pull this out, when you depress the little piece of metal, the little tab that holds it in, it doesn't really spring back. So you're going to need to just very carefully bring it back up, so that when you reinsert it into the plastic enclosure, it stays in place. Just use a fine flathead screwdriver just to pry that tab up just a little bit. It's okay if these get a little bit bent out of shape when you're taking them out, just straighten them out. This is also a really good time to hit these with a little bit of Scotch-Brite lightly to clean off the contact, and use a little bit of isopropyl alcohol. Also, you notice that this, which is going to serve as our ground wire, has 2 wires protruding from it. We only need one of them, so I'm going to cut one of these off. Okay, so you'll have your AC, and then there will be 2 open spaces. The 5 volts will come in the next space, and then second to the end is going to be where your ground goes. So reinsert the green wire there. After you insert it, make sure it's not going to come out. If it pops right back out, then work on your tab to make sure that it's there holding it in place. I've got it firmly in there now. So now we're going to take one of the longer wires that we took out earlier, and we're going to relocate it. I've also tinned the end of this wire. So this wire is going to live right next to this ground. We don't want to forget to spring our securing tab back into place. Okay, that one was a little bit difficult, but I did get it. Okay, so right next to the ground, you're going to reinsert this one, and this is going to act as our 5-volt supply. We want to make sure that we have enough slack to get over here. Looks like we have plenty. Alright, so the next step is to insert the wires onto the connectors on the power supply. Brown wire is going to insert into the center of this connector. Use a small Phillips head screwdriver to tighten the connector down onto the tinned wire and make sure that it's good and tight. You shouldn't be able to pull it out. Then, it doesn't matter which way you put these, because it is AC current, so it really doesn't matter. Just making sure that you get them good and tight. That's our AC connections. Okay, now we'll do the 5 volts. On the PCB, it is markated plus and minus. So remember, green is going to be our ground, so it's going to go into the negative. And that's the power connection's output. Next, we'll work on the power input. So the IEC input and AC line filter is mounted to the back here. The brown wire that's coming in is the neutral. It goes to the fuse on the back. It's a 2 amp fast blow fuse. Our supply then goes through a black and white striped wire to the front switch, and it comes out of the switch in a red and white striped wire. Strip and tin both of these wires. I like to use this Kester 2331ZX flux pen. This is fabulous solder flux. I have this pad here. This is a silicone pad just to make sure that no solder drips off. The kit does include an alcohol wipe. It's a good practice to use a little bit of alcohol on the ends of these after they've been soldered to clean off any flux. Now the next step, use the alcohol pad like to double it over a little bit. Wipe off the inside of the chassis. There's going to be dust and other sorts of stuff accumulated. You just want to make sure that it's really clean. So now we've gotten the inside of that clean. I'm going to wait just a moment to make sure that the alcohol dries completely. And next step that we can do while we wait for that alcohol to dry is to install our power jumpers. The kit includes 3 of these jumpers, but this is just out of convenience. You only ever need to install at most 2. The reason that we include 3 in the kit is because these suckers are really small, and I know how frustrating it can be to lose something on the floor and then not be able to install your kit. So we're in North America, and we're going to install 2 of these jumpers to enable 120 volt operation. I suppose this is a good opportunity for me to talk about why we chose to do it this way as opposed to having a switch. The primary reason is that the switch can accidentally be flipped, and that can cause bad and possibly catastrophic consequences. We find that these units aren't traveling across the ocean often, so technicians that are installing these in a studio or musicians can be pretty confident when they set this up that they know what kind of power is coming into their Eventide H3000. So with that said, I'm going to install these 2 on the 120 volt side. It's very clearly marked. There's a little circle or a square around the 120 volt section, and then a square around the 240 volt section. For 240 volt operation, you only have the 240 volt jumper placed. For 120 volt operation, you have 2 jumpers on the 120 volt side and the 240 open. The next step is to install the power transformer. Before you pull off the backing on the VHB, this is 3M very high bond. This is very high quality sticky tape. Now what some of you people might say, you're using sticky tape? Seriously? Well, trust me, I'm a professional and I've been doing this for a really long time. Not only have I used this to install transformers and Eventide 3000s, I've also used this exact same tape to affix solar panels to buildings and RVs and other things. It's pretty amazing stuff. It can hold 30 pounds per square inch against tear force. Before we install this, we're just going to kind of get an idea for how things are going to fit. So I'm just going to carefully place it in there, and already I can see that I need to train these wires a little bit. Alright, so that looks pretty good. This is going to be how it sits. You don't want it to be resting right against the bottom side of this chassis. You want it to be up just a little bit, just so there's enough clearance. But really the hardest part is just fiddling these wires around. And I suppose if you wanted to, I've never done it this way, but if you wanted to, you could install the transformer and then install the wires afterwards. But I think that that would be pretty fiddly and probably not very easy to do. So I'm happy with how this looks right here. And I can see that our supply lines are going to be able to reach with plenty of room. So I'm going to go ahead, grab a tweezer, and remove this backing from our 3M VHB, very high bond. You want to make sure when you're doing this that you don't use your fingers. You don't want to get human hand oil. Our hands tend to be very oily. Of course, you'll probably be wearing rubber gloves like I am, but even still, keeping this tape as clean as possible until the point at which it gets attached to the chassis is the point. Okay, so get it positioned where you want it. And this tape is very, very permanent, so make sure that it's where you want it to be, and then run her on home. It literally just takes a little bit of pressure, and that transformer is on there. There is no way I'm getting that off. It's very much stuck there. Okay, last few connections. The kit supplies you with a chassis ground wire. This is how we're going to make sure that our power supply is properly grounded, that the earth plane is connected to the chassis, because keep in mind, the original transformer was installed with nuts and bolts and metal hardware, and this is completely isolated because of the rubber. So there's a small spade connector. I suppose you could also put this on before you install the transformer. Just pushes right onto that spade connector, and it'll just clip right into place. And then this is going to connect to, there is a chassis lug right here. So we're just going to loosen that and put this, we don't have to take it all the way out because it's a forked spade. So we're just going to loosen it a little bit and then slip it over. Okay, so there that is. Just gonna tighten up that Phillips screw and make sure it's good and tight. I like that. And we can just tuck this wire up in underneath the chassis. Just enough room for it to tuck safely out of the way. Like that. And now the last two connections are going to be our power input. Excellent. So the final step in this process of installing our transformer upgrade is to remove a load resistor. This resistor is held to the side of the H3000 with a couple of machine screws and nuts on the inside. So I've undone that, and then there are purple wires that supply current through this. The point of this resistor was to basically just make it so the voltage regulator didn't get so hot, even though it had a big, huge heatsink on the back of it. Before they added this along the production of the H3000s, it would get really hot. Anybody who's ever used a SP12 or an SP1200 knows that those external voltage regulators, because of their inefficiency, they get so hot that you could cook an egg. So that's what this thing does. It brings that heat inside. These typically get really super hot. Oops, I blew my glove out. Well, it's all in a hard day's work, I guess. Anyways, so once this is removed, and you certainly do need to remove it, it is not required because of the engineering of our power supply. It is very efficient, it produces no heat, and there is very little lost energy. So you remove this, and I just use dikes, flush cut dikes, to cut the wire. The wire will be on the back side of the H3000. It'll be right back here between the capacitors, and it comes along. It would be right here. You would just cut those, they're usually purple, I believe. Just cut those off. Our kit will include a small piece of wire that is pre-tinned. So all you gotta do is keep track of where that wire came out of, the 2 holes. There are actually 3 holes back here. It's very close to where the 5-volt power regulator was. So you want to make sure that you jumper this wire across the correct holes. Place the jumper wire in there. Use some good solder wick to, once you've cut the wires off, to remove the additional solder and capture the little bits of wire that are left in the PCB. Use a good braided solder wick. Or if you have a vacuum solder removal tool, use that. Certainly those are the best way to go, but you don't really need it. So use some super wick. I like and always recommend people to get MG Chemicals brand super wick number 444 fine braid. This is an awesome multi-purpose solder wick. So just use that. I'm not going to go into the details of how you use solder wick, but clean the holes up. Place the jumper in from the top, and then flip it over and solder that jumper in place. Last thing that we're going to do is test the output. We're going to plug this in. We're going to check the output voltages with a voltmeter. Keep in mind that this is going to be unloaded, so the voltages are going to be, the 5 volts should be right in line with what we expect. The AC voltages are going to be a little bit high. They're going to probably show around 18 volts. That's fine. Once they're loaded down, once the transformer is loaded down, that will come back down within the acceptable range. It's going to be about 15.5 to 16 volts, something thereabouts. Okay, I have the IEC connected, power's off, got our fluke meter here. I'm going to turn the power on. First thing I'm going to do is I'm going to check the 5 volts. All right, now I'm going to switch to AC, and I'm going to check the AC output. 18.85, 18.85, just as we expect. Next step is to disconnect the power, plug in the header, and power on our totally silent, freshly repowered H3000. Moment of truth. Voila. Totally silent. It's awesome.